Hello everyone, welcome again to this video, and in this video we shall talk about the variance of exponential distribution, because we have already started with different kinds of distributions, and in this one we shall explore more about how to find the variance. So in the previous one what we did was, let me have a quick recap. So when x follows exponential distribution with parameter lambda, it means that the PDF is given by f of x equals to lambda into e to the power minus lambda x, where x is greater than 0, right? So this was given, and we also found the expectation the expected value of x, that is the value of x which is, let's say, its average. We found that the average was simply one by lambda. So it's just the reciprocal of the parameter. Now in this section we aim to find out about the variance of the exponential distribution, and in the coming sections we shall also see how to find the MGF, or the moment generating function of exponential distribution, and also the median of it. So let us go forward, and first before that we shall also define what is the CDF. So the cumulative distribution function is defined as capital F of x so it basically means that the probability of x less than equals to small x. That is how the CDF is defined. Okay, and we shall see that in this case the CDF is we know what to do in order to find CDF from the above formula. So we just integrate simply minus infinity to x fxx dx, and now, well, small x is greater than 0 because all the arguments are greater than 0. So again, as usual, we can divide it into two intervals, minus infinity to 0 fxx dx plus 0 to x f of x dx, right? Now this portion is 0 because the function is identically equal to 0 here, and this portion remains. So we only need to find 0 to x f of x dx, right? Now we know the value of f of x dx, which is basically 0 to x lambda into e to the power minus lambda x dx, right? Now doing the antiderivative, we get that this is equals to minus lambda by lambda e to the power minus lambda x 0 to x, right? Since there is a minus involved, what we get is this. We put in x first, we get minus e to the power minus lambda x, and we get minus of minus e to the power lambda into 0. So since e to the power minus 0 is 1, we get minus e to the power lambda x plus 1, or in other words 1 minus e to the power minus lambda x, which is the CDF. So basically what it means is It means that the probability that x is smaller than or equal to x, which is a certain real number, is equal to, which is the definition of CDF at the point x, and it is equals to 1 minus e to the power minus lambda x. And in order to check that if a CDF is a valid CDF, we need to do is as follows. We need to check that x tends to plus infinity, f of x is equals to 1. Now this is true because since lambda greater than 0, we know that limit x tends to infinity e to the power minus lambda x equals to 0 when lambda is greater than 0, right? Therefore limit x tends to positive infinity, f of capital F of x, which is the CDF, is equals to limit x tends to positive infinity 1 minus e to the power minus lambda x, and this is in turn equals to 1 minus limit of x tends to positive infinity e to the power minus lambda x, which gives you 1, because as we already told you that e to the power minus lambda x as x tends to positive infinity is 0 whenever lambda is positive. So this completes the part for CDF, and that is the CDF for the exponential distribution. Let us talk about the variance. So the variance of exponential distribution, or for that matter any distribution, is defined as follows. So e of x square minus e of x whole square, that's the variance of the distribution. Now in order to find the variance for exponential distribution, we need to find first the second moment, right? So let us find the second moment. So it is given by x square into f of x dx. Now obviously this x square into f of x dx, the limits are from minus infinity to plus infinity. And as we have seen before, since the region of integration is 0 to infinity, this basically means we are integrating over 0 to infinity, because the other part would be 0. This would mean that we are going to put the value of f of x dx, which is x square into lambda e to the power minus lambda x dx. So what we did here was we took out the constant lambda outside and we denoted this particular integral here by I of lambda. So we are going to evaluate I of lambda as follows. So what I'm going to do is I'm going to evaluate the integral first and then I'm going to explain how we did that. Anyway, so this is how we are going to evaluate it. So observe that when we integrate it by parts using first function as x square and second function as e to the power minus lambda x, we obviously get this part here because the antiderivative for e to the power minus lambda x is e to the power minus lambda x by minus lambda, and well, as usual this limit would always go to 0 because for the infinity part we see that limit extends to infinity. X square by e to the power lambda x is 0, and if you put in 0 it's already also 0 anyways. And in the next part you differentiate 2x, so it's 0 to infinity. Differentiating x square will give you 2x, and again integrating this will give you e to the power minus lambda x by minus lambda, and this minus combines with the minus outside to make it a plus. So this is the resulting integral, and you can take 2 by lambda outside because it is just a constant. And what you see here is actually reminiscent of what we did in the last lecture about expectation. And you see, if you have an extra lambda here, you can easily write this as the expectation of x, right? Now carrying forward from this step, expectation of x was basically 1 by lambda, so this integral is equals to 2 by lambda cube. Okay, so putting it back, what we will get the answer. So therefore so this is the second moment. Now what we can do here is we can find the variance easily now by using the given formula, which is so var of x equals to the formula being e of x square minus e of x whole squared. So it's basically 2 by lambda squared minus 1 by lambda whole squared, which is 2 by lambda square minus 1 by lambda square, which is basically 1 by lambda square, which is the answer. So this is the variance of the distribution. So in the next sections we shall see about more higher moments, and ultimately we can go to moment generating function. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also, you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.